In this video, we're going to discuss turning points of graphs. So on the left, I have a cubic graph, and from this, we can see that there is two turning points, there and there. That is when the graph goes from being an upwardly position and it turns and going in the downward direction. Now, we're interested in working out where these points actually are. And actually, these are when the gradient is 0. So here, the gradient is positive, and after this point, the gradient goes to being a negative. So to go from being positive to a negative on a graph, we have to get to this point where it equals 0. So a turning point is when the gradient equals 0. And if we can find out the positions where the gradient equals 0, this tells us our turning points. So how do we do that? Well, we find the derivative, because the derivative gives us our gradient. When we differentiate our graph, that is the gradient of our graph at any given point. Now we want to find it when it equals 0. So we're going to make it equal to 0. We're then going to solve for the x bit, and we're going to substitute this x bit into our y to find out our full coordinate. So let's look at an example. We've been asked to find the turning point of this equation here. So first thing we're going to do is find dy by dx. So we're going to differentiate this thing here. So we are going to multiply by the power. So we're going to multiply this 2 by this 3 here equals 6. And we're going to decrease the power by 1. So we got power of 3. We're going to decrease it and make it 2. We're going to do the same for the next term. So we've got a minus 3 here. We're going to times by the power. So minus 3 times 2 is 6. Decrease the power by 1. It becomes just x. And then the last one, we're just going to remove the x bit and have it as 12. So we need to solve when this thing equals 0. Depending on your question, if it's in a calculator or non-calculator paper, if it's a calculator, I would very much do this with a quadratic formula approach. If this is non-calculator, which it might be, then we can do this via factorizing. So I'm going to use the old Hegarty method, or whatever you call it. We're going to multiply this last term by the 6 out the front. So we're going to have x squared minus 6x minus 72 equals 0. And then we're going to factorize this line in the normal way. So what multiplies together to give me 72, or minus 72, and adds together to give me minus 6. So we'd list out our pairs, 1 minus 72, minus 1, 72, dot, dot, dot. I'm going to assume that we can do this, and I think if we end up with positive 6 and minus 12, when we add that pairs together, it will give us minus 6. So we're going to put this in. So this is going to give us a plus 6 here and a minus 12 there. But remember, this isn't just x squared. We've kind of done a little bit of higgery-pokery mathematic magicianry here. So we're going to shove our 6x in front of it. But again, we messed a little bit about with it. We've times by 6. So in one of our brackets, we're going to have to divide by 6. Now in this answer, it doesn't actually matter which one we do it by. So I'm going to divide this first one by 6 to get me x plus 1. Now this thing is the bit that equals 0. So we can solve this in the normal way, either x plus 1 equals 0, or 6x take 12 equals 0, and we solve each of these. So we'll take away 1 from both sides. So x equals -1, or we'll do add 12 to both sides, divide by 6, x equals 2. So we're going to end up with 2 turning points here. But these are just the x values. These are just the x values. We want the whole coordinate. So we're going to substitute it into our original equation, each one of those to find our full coordinate. So I had y equals 2x to the 3, take away 3x squared, take away 12. Yep, that's right. Sorry, 12x. Yes. So if I substitute this one in, we're going to get y equals 2 lots of -1 cubed, subtract 3 lots of -1 squared, subtract 12 lots of -1. -1 cubed is -1 times 2, which is -2. -1 squared is +1, but we're timesing it by -3, so it's still -3. And -12 times -1 is a +12. We sort that all out. -2 -5 +7. And we can do the same for this other one. So we're going to substitute this into our equation. 3 lots of 2 squared, take away 12 lots of 2. 2 cubed is 8, 2 lots of that is 16. 2 squared is 4, 3 lots of that is 12, and 2 lots of -12 is -24. So our y bit, we got -36 plus 16, which is -20. So our 2 turning points is going to be is -1 for our x bit, and +7 for our y bit. And we got 2, -20. So those are our 2 turning points.